morning, everybody. I'll be quick because it's getting late and I'm sure you're getting hungry, but let's get going. What I'll show you today is, I see that our notes are not here, but we'll improvise. It's the next addition to a series of urban sensible projects that are innovative both from a design point of view and from a sustainability point of view. There's a lot of projects that claim to be sustainable, but sustainability goes behind the energy aspect of it. It's to do with the the social aspect of sustainability. We are going to be talking about this project in Shanghai. Shanghai has a lot of development built over the last 20 years that are not very sustainable at urban scale because it's basically very tall needles that try to define an innovative image but have no relationship with the urban scale, with the ground. Often the only thing that these developments have around them is just some planted trees and some sort of landscape. But the imaginary of Shanghai, the Shanghai of the early 1900s, of the band, is completely lost in the development of Pudong. And this is what we have been trying to avoid in this development just off of Century Avenue on Yanggao Road. We always say that to do a great project, you need to have a client that share your vision. And we've been very lucky because on this project, we had three great clients. On the financial center, we have the Stock Exchange, the Future Exchange, and the Clearing Corporation, who have, from the beginning, shared and sustained a vision together with the city to build a project that was somehow different, a project that integrates a series of public functions within the project. And also that connects to the city. You can see we have a plaza here all around the buildings, but no podium. And this is something that the clients and us have been pushing throughout the project. This allows us to develop a project in which we are trying to layer in the vertical levels of the buildings those spaces, those urban spaces that were once part of the imaginary of the city that belong to the ground level. We are now trying to bring those spaces up in the air, and you can see in this model image this sort of layering. We have the ground floor plane that is free from a podium. We have this plaza that connects to the city, and has planting and parks that connect to the river and the park that is on the other side of this road here that is currently being built. You can see how the ground floor plaza then sinks into a lower plaza that connects the lower levels of retail to the realm of the city. And within this plaza, we have a theater, 800 seats theater that is part of this complex. You can also see the bridge, this element, this connectivity that brings a public space. As I said, there's public function in this building. In this bridge, we're hosting a museum and also an education center. So we have a bridge that spans 130 meters from one building to the other, and it's starting 40 meters up in the air and concludes 60 meters up in the air with this sky garden, which is basically what we're trying to say, trying to take these functions that once existed in the plane of the city and trying to bring them up in the air. You can see in this image how the buildings are very particular in their configurations. These are very, very big buildings. The complex overall has over 500,000 square meters of area. Half of it is a little bit less than half is underground. But these are big buildings. The biggest one, SSC, the Stock Exchange, is actually 72 meters by 72 meters. This was also a challenge in terms of approval from the city because we know it's a little bit above what it should be. And the reason why the buildings are so big, because the client had very specific projects. They needed column-free spaces for trading floors, multifunctions floors for conference areas, and therefore we developed a concept of buildings that have split slabs and an atrium in between. This atrium allows us to do two things. One is to bring the public realm into the building, making it into a transitional space which is semi-public and which we can see appear allow us to create terraces, bridges, a series of spaces that implement the office space and that also connect the two slabs together. And at the same time, this allows us to break down the mass of the building, and therefore it allows us to build a building that is so big. The last level of the stratification of the city in the sky is the top of the buildings, where the buildings are connected by this level, which we call clubs, which are in reality spaces for ceremonies, signatures, lectures, and on top of them there's actually more roof gardens and then screens to top the buildings, because in a city that is so vertically developed like Shanghai, the scale of the sky, the way the building connects to the sky, is equally as important as the way the building connects to the ground. You can read a sort of stratification even in this image. It shows a little bit the elevations of the buildings. You can see there's a base to the building. You can see there is a middle portion in which the buildings connect. And then you can see the volumes of the building developing, split by these atriums. They create a certain articulation within the building. This is very important from an architectural point of view. When you do a building of this size, it's always very challenging. How do you design the building so that it doesn't look like a giant box of glass? And the way these masses are articulated really solves this problem. This is a view from the back, and you can see how the atrium cuts the building in half, apart from where there is the spatial floors that require that column-free space. And the atriums are actually extremely transparent. So they break the volume, allowing for your eye to see from one side to the other of the complex. In this section, you can actually see how the building is completely split, and there's only a few connections. The first one, the main one, being the bridge level, where the museum and the special functions are, and then the bridges connecting all the floors, the office floors together, some office spaces, and then terraces, which create a new type of space in the office, a space where people can interact, something that is missing in a lot of buildings nowadays. It's sort of like, we call them sky gardens, some sort of sky plazas where people can go and have short meetings, have a coffee, rest, take a break from their office working routine. And then the buildings are reconnected at the top in these ceremony spaces, which are more formal for public events. This is a view of the lobby, and you can see the lobby has a very monumental scale. It's 40 meters tall. It's connected to the exterior of the plaza through a very transparent cable facade. And all the floors, it's true here in the lobby and also in the atrium above, all the floors actually open into the lobby. Yesterday, during the afternoon session, somebody from the audience asked a very intelligent question, and it was the discussion was about these connectivity spaces, these spaces for people to interact. And the question was like, how can we change the habit of having elevators in this clunky core of the building that basically bring you to from ground to your desk? How can we change this experience and make it more like the horizontal experience of working in a city? And this is what we've been trying to address in this building. All the elevator lobbies are actually open through balconies into the atriums, which allows a user to always have a visual contact with the ground plane is coming from, with the scale of the building that you can see in its entirety through the atrium, and with the floor he is going to. This is a plan of the bridge level of the museum, and this is where the concept of the building being a split slab really comes together, because it allows us to have this space here completely column-free. We have a space that spans 24 meters and is cantilevering for over 130 meters, and allow us to have these large spaces for exhibition halls, trading floors, etc., etc. They will be otherwise very complicated to accommodate in a building without creating a podium next to the tower. And this is a view of the garden space that we are trying to reclaim in the height of this development. From this space, of course, there will be terrific views to the city, but also you can see the transparency of the atriums. How is it possible to read this axiality and to read through the building volumes? One very important aspect, and this in this was very critical, the support we had from Werner Sobek's office and from CIDR here in Shanghai, was the structure of the bridge. There's a lot of buildings that try to do some very complex moves that then are not solved structurally, and usually they result in giant complicated steel cages. They really destroy the experience of the space you're trying to build. We went the other direction. We say we don't want to have any columns, we don't want to have any bracing in this bridge. So the engineers work with us and create this concept of a kind of road bridge construction with this large girders spanning these 130 meters, which don't need any vertical or bracing support. The whole bridge, as you can see in this model, is supported of the elevator cores, these very small towers that connect the bridge levels to the ground, and otherwise is free from any vertical and diagonal structure. This was very important because we are creating some column-free spaces for a museum, for a training center, and we wanted to keep them that way. This was very challenging in terms of approval with the city because, as you know, Shanghai is in a very high seismic area, and the great thing of the systems that the engineers develop is actually the bridge is free to move at its end, so that it doesn't transfer building loads onto the bridge and onto the next tower. This is a view of the space that we actually managed to keep very open, and the interesting thing is that the facade is actually 50% solid and 50% glaze. This allows us to control the light into the space because, you know, being an exhibition space, you also need to, you can't just blast it with light. And this is the plan of a typical office. You can see what I was saying before, all the elevator lobbies are actually open into the atrium space, and you can read very easily the two halves of the building, the two twin slabs connected by a bridge on every level. The buildings are very efficient. Every floor plate has a lead span of between 12 to 15 meters. The areas are very large. They are often over 2,000 square meters. And most of all these spaces, all these office spaces, have great views to the outside. They benefit from daylight. And this has a great impact on the quality of the office space. This is a Class A office space. This is the atrium, the view of the atrium looking up. These atriums are extremely tall. The tallest one is 120 meters by 24. We were trying to keep it as transparent as possible, as Sobek assisted us in designing this facade system, in which, as you can see, there's no columns, there's no bows, there's no trusses. The whole system is working on tension cables to minimize the structural impact. Let's talk about the sustainability a little bit, the sustainable energy aspect of a building. A lot of architects and engineers, unfortunately, often retrofit sustainability to a building. But that's the wrong approach. The right approach is to design the building so that you don't create additional loads onto the project. Because the greatest savings in terms of energy consumption can be achieved in the massing, in the orientation, and in the envelope design of the building. And this is what we have been trying to do, working very closely with WSP, to deliver an integrated design that would have been solving a lot of planning and programmatic issues, trying to achieve this vision of a vertical urbanism, and at the same time deliver a very performing building. We work very hard trying to integrate a series of systems, maximizing daylight, minimizing the loads. The buildings have data center, which represent, of course, probably the largest load on the project, and we work very hard to make these loads as sustainable as possible. There's a series of measures that are integrated in the project, such as high-performance chillers, tri-generation, ice storage, and through all these measures and through the integration of the design and of the architectural aspect and the mechanical aspect, we managed to achieve a 28% reduction in energy consumption, which may not seem big compared to other projects we've done in the past. But if you consider that the data centers that are in this building actually are responsible for 80% of the energy consumption of the project, then you can understand how offsetting this enormous load was actually very, very difficult. The other aspect of saving on resources is water consumption. There's probably less water than petrol and coal in the world, and we were building such a big site that being able to recapture water was a critical aspect, and we actually managed to reduce the water consumption of over 60%. As I was saying, doing this required a lot of integration between architecture and engineering, and the atrium probably is the space that required the most work from the design team point of view. A whole series of analysis have been performed on the atrium, try to make it work so that it's a space that can work without air conditioning, but through natural ventilation, allowing this space to act as a buffer between the exterior and the interior, minimizing the exposure of the interior of the building to the exterior, and at the same time allowing for additional daylight to enter the building. So a series of performances have been done to study how the air moves within the atrium and allowing then for natural ventilation in the atrium, which is actually not climatized but works with the spill air from the offices. You can see in this analysis how abundant the daylight is on the floor plans that have been designed to actually maximize this aspect and allow us to achieve turning off the artificial the artificial lighting in favor of daylighting for 70% of the usable hours. These are these floors that I was mentioning, the special function floor, where there's conference floors, in which we need these 24 by 72 column-free spaces. These floors were very challenging from planning and fire approval, life safety design, because these floors have the biggest one is 5,000 square meters of area. And of course, it's 3 fire zones. There needs to be separation. And we work very closely with the client, the fire department, trying to optimize the occupancy level of these floors and not not overdoing the exiting through the course. Otherwise, the floor plans will become not very usable. The usability of these floor plans is close to 80%. This is one of these spatial spaces for trading. These are some of the spatial office spaces I wanted to show you, in which we are creating some office with terraces that actually open into the atrium. The structural concept is very interesting. It's a mega structure. There's the 2 halves of the tower are actually acting as 2 giant columns, and they're connected through bracing whenever we have a slab that goes across the atrium. So being the bridge level of these office levels or at the top below the roof grid, so that it's not impacting the architecture. These are the club spaces at the top of the buildings with these large central halls for ceremony events, which will have some great views to the city, of course. One other aspect of this stratification of the building is actually in its facade. The facade of this building was very challenging because the facade code here in Shanghai is very stringent. We had to limit the glass area to 70%. As Anthony was saying earlier, to all the architects, actually there's other ways to do facades that are not glass. So we try to make the facade work with the functions on each floor. And therefore, we articulated the building in a lobby space in which we have 50% glass, 50% solid panels with laminated stone that connect to the data center floors. The data center floors, of course, we didn't need any glazing. There's nobody in there. And actually, the glazing will only increase the heat load, the cooling load in these floors. So we created a facade that is 100% solid, offsetting Therefore, the 70% requirement from the facade of the office is where we want it to be transparent to here, where we want to be less transparent. And then again, 50% solid facade in the bridge to control the daylighting, and very transparent then office floor with the maximum transparencies left for the atriums where we have over 90% transparency. In the office floor, to maximize the glass area, we actually exaggerated the spandrel a little bit to offset this requirement and put on the exterior the vertical mullions. This also allowed us to do other two things. One was to use these fins as shading elements. The other one was to clamp the glass, which is one of the requirements of the code here. The glass needs to be mechanically fixed. So I always say integration is the best way to design. If you can get one element to do 3-4 things, you're saving money. And so you should do it. Also, having this spandrel and these fins created a certain articulation in the skin of the building that you can see here that allows to break down the volume a little bit. The floors, very important, have windows. All the office floors have natural ventilation. The climate in Shanghai allows us to do so, and we take advantage of that using natural ventilation in all the office levels. Of course, the windows are controlled through a central system that allow us to close them when it's not possible to use them. These are some detail of this condition with the windows, and these are the fins. You can see they are not decorative. They actually used for structural purpose to hold up the glass. This is an image of the mock-up that we have. We've done a series of mock-ups, of course, during construction. This is one of them. You can see the floor-to-floor are very tall. They are over 5 meters. You can see this articulation of the window, the fins, and the spandrel. The office floors use underfloor air distribution. This helps the air working with the system using the convective moves of the air that as heat heats up from the loads of people and computer goes up. And this works much more efficiently than a traditional VAV system. And actually, these graphs show this energy reduction from a VAV to an underfloor system. This is the cable facade. As I said, it's a tension cable system. The vertical cable carry the gravity load, and the horizontal cable are tensioned to pick up the wind loads, therefore minimizing the thickness of the structure. Extremely complex analysis had to be carried out, wind analysis to minimize the load on such a minimal system. And also for approval, this was very challenging because, of course, the code doesn't go in the specific of such a system. So a lot of performance analysis had to be carried out in order to have these cable facades approved. Here you can see the facade of the bridge with a 50% solid. And here some mock-up that actually are testing different materials, stone, stainless steel, for the solid areas. As I said, a large part of the project is below grade, and we try to open it through the sunken garden. There is retail, there is a fitness center, and most importantly, there is a theater, 800-seat theater, which was also very challenging to get there under a fountain and in a space where the fire department wasn't too happy to have it. But we worked really hard with RJA and with the client, and we did a series of performance analysis that allowed us to get the project approved. You can see here the hall of the theater is actually separated from the exterior with glass walls. It's a stick system with a cavity and special laminated glass both on the inside and the outside. That allow us to have, these are some analysis of that performance study done for life safety. That allow us to have daylighting into the theater in case it has to be used for conferencing or presentation. And then pivoting panels on the side of it allow us to close it and create the necessary acoustic performances for chamber music or for Chinese opera or for orchestra performances. The project is currently under construction. It's been under construction for the last 3 years. The fact that the site is over 250 meters by the 150 meters meant that the first year was piling for, I don't know, many thousands of piles. The second year was creating the retaining wall. And over the last year, we have been building the ground floor, the basement structure. is going top down, so the ground floor slab is completed, and they are building their way down. We know that they are now on the 4th level below grade. The towers should be out of the ground by mid next year, and the building should be completed by the end of 2017. That's all I have. Thank you, guys.